Hey guys, so this is part two of our function transformation lesson. The first lesson is on our YouTube channel, so make sure that you go ahead and check that out. But if you've arrived here and you're here for stretches and compressions, we are going to go over vertical stretches and compressions in this video. And if you'd like to see horizontal stretches and compressions, I'm also happy to cover that, but those are less common and you'll see those more in higher level courses or an honors class. So again, just go ahead and drop it in the comments if you need a video on that. I'll be happy to do it. So let's go ahead and proceed by doing some vertical stretches and compressions. Essentially, what you need to know is that when you stretch something, it's going to get skinnier. When you compress it, it's going to get wider. So let's go ahead and define what that looks like in the actual function. This is the vertex form of our parabola. And what a stretch or compression is going, or where it's going to be found, is this a value. If the absolute value of our a value is between 0 and 1, then this is a vertical compression. Okay. You're going to think of a hamburger where you're pressing the buns together. It's going to get wide, okay? Or a smiley face. If you have a that is greater than 1, that's a vertical stretch. And the way to think about that is if you take a rubber band and you were to pull your hands from the ground to the sky, the rubber band would get super skinny. Okay, so it's going to become very narrow. You might also see these phrased as a stretch, excuse me, a compression might be called a vertical shrink. It just kind of depends. I will use compression and stretch exclusively though. So let's look at this how it might be phrased in an actual problem with real numbers here. In the previous video, I went ahead and talked about our internal shifts. So this would mean a shift to the left 5, and this is a shift down 3. Now this half out here falls within this range here between 0 and 1, and that means that it's going to be compressed. So our graph of our parent function, again, we're just going to sketch it, is going to start off at the origin. We have a shift to the left 5, 1, 2, 3, 4, 5, and down 3, 1, 2, 3. And we are compressing, we are pushing together this graph in half. So all of our y values are going to be in half. So this is what our graph is going to look like. Essentially, it's going to be half the height. That's a way to think about it. Kind of half the height that it would be, or it's going to increase half as fast as it would normally. So hopefully that makes sense. Now let's go look at a stretch example. Here we have y equals 6 times the absolute value of x minus 3 plus 7. We have this 6 outside of our grouping symbols here, which means that this graph is going to be stretched 6 times as fast as it would be. So let's look at what our graph would look like here. We have an absolute value graph. So our parent function is going to look like the v. And we are shifting this graph, we are translating this graph 3 units to the right and 7 units up. So we're going to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Now we are going to stretch this graph 6 times. Okay, and that means our graph is going to look like this. And here you can see that our graph is stretched and the V is much skinnier. So that's really as hard as this gets. Um, some of the biggest mistakes that I've seen students make are forgetting the simple rules about the transformations. So, as I mentioned in the previous video, I'll go ahead and recap it here for you guys as well. I would definitely become familiar with these parent functions and how these transformations apply. Okay, and I will go ahead and write here that a this determines the stretch or compression. I didn't put that in the other video because I wasn't covering that then. But this is stretch or compression and also has to do with the reflection as well. So you can screenshot this if you want. This right here is very helpful to go ahead and memorize so that you know how these graphs are moving. And then this part up here kind of gives you a general idea of the shapes of the graphs and some of the most commonly found parent functions. So I hope that this was helpful. Make sure that you let me know if you need any assistance with anything else regarding function transformations. And if you have any questions, go ahead and drop it in the comments. But thank you so much for being here, and I hope that you do well on your next assessment.